Hi, my name is Stevie, and I'm here with Daniel. We are affiliates of SENSORICA, and we're working on the PV project. And we already started milestone 2 of this project, which is about prototyping. And Daniel is trying some 3D printing here, different materials for different parts. So we're going to go through them, just take a look at their properties, and to give an idea about where we are in this prototyping stage of the photovoltaic cell.
Okay, so the first part I 3D printed was the most critical part in the whole assembly of the gimbal. Is the one that carries the most weight on a small area. So if you want to take a look at the screen now, you can see the whole assembly design. So this is the part I'm talking about here. You can see that most of the weight is sitting on this part. So that's why it's the most critical part in the whole assembly. And because these motors are holding only with 4 screws, and the most critical area here for stress is in this side of the part.
And we also wanted to see if the gravitational force that pulls the stage down creates some bending of this thing. So we go back to the actual piece.
So the first time I printed with PLA PHA, which is a very popular substance for 3D printing, and it's very stable. But I thought it wasn't very stiff. It proved to be stiff enough for this application.
So for the bending, I think this is really stiff. I mean, you can put up more than a kilo on it to bend this solid part.
So this particular piece, the setup in the 3D printing was that there is 2 passes for each wall.
So that makes the thickness of the wall, right?
Yeah,
you have an infill inside.
Yeah, it's 20% infill, and it makes a structure inside the part that makes it sturdy, but yet very light because it's only 20% infill, and the rest is air.
So can you talk about the fiber and the way this thing was printed?
Yes. Okay. So it was important to print it this way because now all the layers being horizontal, the fiber in the piece makes it more sturdy. Whereas if you print it like this, these layers here will be horizontal, and here is going to be very strong. But horizontal layers in here and in here would make it brittle.
So you will have a weak plane.
Yeah.
And then you can break by applying some pressure.
For every part, it's important to choose the right orientation on the printer, so that the fiber is in the right direction for the sturdiness and stress.
So here we see the screws where the motors will be. We have here a stepper motor, but this will use actually a brushless motor, where the motors will be attached. I think one of the problems with this thing is that if the fiber is longitudinal and the piece has tension this way, it might crack. So we're trying to figure out how to put another piece over it with the fiber in the other direction. It's basically something that goes over, or Daniel might have some other ideas to have 2 pieces glued together with some other screws. Anyway, there's still some work to do with this.
We still don't know if it's going to be necessary, if the weight that is added here is going to be enough to make it crack. I don't even think so.
So this whole thing weighs, what, 150 grams?
No, that was 54 grams.
54 grams for the whole thing, because it's almost empty inside, right? 50% infill.
This here weighs 60 grams, and you can see it's not a finished part. You can see the infill inside. This is 20% infill and 80% air in the part.
So we can talk about these things now. This is from the clamp holding the sample. So maybe we'll go back to the screen and show where this piece fits on the whole thing.
Okay, so this is the clamp. It's a vice type clamp that self-centers, and it's sitting in front of the second motor of the gimbal, and it's holding the photovoltaic sample that we need to test with the light from top, and it's holding also some micro manipulators that are carrying some gold wires that will make contact with the sample to measure how much electricity the sample is generating. And it's a very simple mechanism inspired by an English wrench. But actually these arms can be taken out and reversed to clamp smaller samples in the middle. And they always self-center because see, it's actuated by this wheel, which is holding two worm screws,
which are here, right?
yes. So yeah, these are the parts for 3D printing, the way they should be oriented in the 3D printer and how they should be printed.
So essentially what we showed is these two parts here, right? So we're going to talk about only these two parts. Okay, so we go back to the real piece. So we tried actually two materials for this thing, Daniel, right? This is nylon. Again, these are the two pieces, the body of the clamp. The clamp is going like this. So this is nylon, is very tough to break, but at the same time is very flexible, right?
We don't need that. So
Exactly.
we made a mistake with this material, but it's a very good material for other applications. So finally we decided to go back to PLA, PHA, which is natural, and it's very, very strong. It doesn't warp, so it prints nice and straight without bending.
Yeah, actually this is very tough, and we're wondering if it's not an overkill, the amount of material we put on it.
Yeah, it was a 6-hour print.
Mhm.
And I can cut this by half easily for what it has to hold, and we'll see. But yeah, this material actually is more like pasta than like plastic, so it has a problem with humidity over time. So we bought a coating for it, so it protects it from humidity and ambient temperature and so variations.
So okay, so let's see how these screws. Now we're just talking about tolerance, right?
Yeah.
So these parts will hold together, and the part here holds the screw that it's actuated with this little wheel, like we saw in the design. You can go back in the video and check, and then you have the clamp moving sideways, right? So this is where the screw is going to go, and there's another piece that goes over, and then this is held together by some screws, right? So you have some bolts here that fit into this
M6 standard.
M6 bolts that fit into this hole, and then they hold in place with an M6 screw like this.
Actually,
So we're just going to see how it
Screws and nuts.
fits together. Okay.
of course, it's easily editable if you don't have the same screws and the same nuts. You just need to change a few diameters.
Okay. So there's also magnets, because this thing, I'm just going to take it apart. There's a metal plate that will hold the micro manipulators. We're not going to talk about the micro manipulators. Essentially, we have to fix a metal plate on this piece. So there are some holes made for some neodymium magnets. We have 3 here. So this was made for this precise magnet size. So
It's a standard magnet. You can order them for very cheap, and
so just inserted the magnets into the piece
with glue.
Yeah, you can put some glue to hold it in, and then just to see how the metal plate would stick to it. And Daniel came out with another idea, which is to use this kind of magnetic sheets. These are the same things that you put on your fridge. So the micro manipulators, which are other parts that will sit on top of that, would have other magnets on top of them, and we need some rubber to ensure that there's enough friction.
So yeah, only 2 magnets gives us enough hold for the micro manipulators not to move while it's kind of sturdy. It's sturdy enough for the other weight they need to.
Exactly. So these little magnets will be inserted into the micro manipulators, and the bottom of the micro manipulator would be covered with this sheet, which is kind of rubbery and magnetic.
Easy to cut, to size, and to fit.
Exactly.
Yeah.
Well, that's it for today, and we maybe go to see some happy 3D printing.
So yes, here we can see how it's done behind the scenes. I'm using black PLA PHA because black is going to absorb light, and we need to eliminate ambient light in the PV chamber. And the PLA PHA, it's a easy to use material, although I have some problems with retraction, because here we are using a Bowden type 3D printer, and it's pushing the plastic in here, and by the way it gets here, there is some friction and there is some elasticity, so retraction and extrusion is never really good on a Bowden type 3D printer, but it compensates with liquid cooling to keep the distance of filament that is melted, to keep it really short. But you know, we can see that it's not controlling very well. Some materials are better for this. Every material has its own properties and problems. So it's a little bit of iteration and trial and error, and once you get the right parameters, you're ready to print your parts.